All right, we're going to talk about simplifying square roots. We'll deal with simplifying cube roots later, but right now we're just going to deal with square roots. So simplifying, as always in math, if we can simplify, we want to do that. Just the same way as I would never give 4/6 as an answer, I would want to simplify that to 2/3. We have the same concept with exponents, or not with exponents, but with radicals, with square roots. If we can simplify it, we want to do that. And so the concept here is we're trying to pull out these perfect squares. So I think a good strategy, especially when we're just reviewing, is to write down your perfect squares up here, because it's just a nice visual. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. There's obviously more perfect squares that we could pull out, but these are going to be your most common ones. We never really deal with 1 because 1 is a factor of everything, so that's not very helpful. So let's go ahead and do a couple of examples from page 204. I'm going to do the first 2 examples kind of from each quadrant. So problem number L, we have the square root of 8. So what I want to do here is I want to see if I can pull out a perfect square as a factor. And I can see that 4 is a factor of 8. So I'm going to rewrite the square root of 8 as the square root of 4 times the square root of 2, because 4 times 2 is 8. And that's very helpful to me because I can simplify or reduce the square root of 4 to be just 2. So this becomes 2 times, and I can't simplify the square root of 2, there's just no other way to do that. So my answer is 2 square root of 2. I suppose you could write it as 2 times the square root of 2, but we generally write it without the multiplication sign. We just assume that it's there. Let's go ahead and do problem number I. And the square root of 45. Again, I'm looking for a factor that's a perfect square that I can pull out, and that would be 9. So I'm going to rewrite the square root of 45 as the square root of 9 times the square root of 5, because 9 times 5 is 45. I'm going to simplify square root of 9 to be 3. Square root of 5 just can't be simplified at all. So that becomes 3 times the square root of 5. Now this right here, these are the exact values because the square root of 8 and the square root of 45, they are irrational numbers, which means if I type them into my calculator, I'm going to get a number that just repeats on and on and on with the decimal on and on forever with no pattern. So I would have to estimate that because I don't feel like writing decimals on for the rest of my life. But this number here, this value here, it contains all of the infinite decimals of the square root. So this is the exact simplified answer. And then if I wanted to find the approximate, I could put that into my calculator as well. But right now we are practicing on reducing and keeping that exact answer as much as we can. I'm going to go over here to this next quadrant and do the top 2 problems. So here's problem number S. 5 times the square root of 18. So here I have a whole number times a square root. So I'm going to try to simplify this square root. So I have 5 times. I'm going to try to pull out a factor of 18. That's a perfect square. That's going to be 9. So I'm going to rewrite square root of 18 as the square root of 9 times the square root of 2. So now I'm going to simplify. Again, 5 remains the same. Square root of 9 is 3. Square root of 2 remains the same. And then I can go ahead and simplify this part. 5 times 3 is 15 times the square root of 2. Let's go ahead and do the next problem. Problem U. 3 times the square root of 28. Again, 3 is my whole number, so that's fine, but I want to simplify this square root of 28. I'm going to, let's see, 28, that is 4 that I can factor out. And then square root of 7 is my leftover. Square root of 4 is 2. 6 times, well, 6, that's my answer is 6. So 6 times the square root of 7. Oops, there we go. Sorry, down there. All right, let's see what happens when we have a negative in there. So I'm gonna go ahead down to this quadrant here and do problem H. All right, so problem H, we have negative 3 times the square root of 54. So this is the exact same thing as before. Oh no, but I have a negative in there. We can still do that. I'm still going to try to rewrite square root of 54. So I have negative 3 times, let's see, square root of 54. I can factor out a 9 out of that. So I'm going to rewrite square root of 54 as the square root of 9 times the square root of 6. And that becomes negative 3 times square root of 9 is 3. Negative 3 times 3 is negative 9 times the square root of 6. And that is how you reduce your square roots.